This video is all about springs and what happens when you pull on them. Now, we really need to know a bit about a bit of terminology. And if we apply a force to a spring and it gets longer, then we can talk about a tensile force. So something which is in tension is something that's basically being pulled. But sometimes we have a spring which we can then compress. And if we have a compressive force or compression, that's when the force is acting inwards. And it tends to be that things in tension get longer, things in compression get shorter. So here I have my retort stand, my boss and my clamp. And what I'm going to use is just the rod end of this. Now if I take my spring, what I can do is I can measure the original length of the spring. Now as I add more and more masses using a mass hanger with a load of 100 gram masses on, as I put this on here, what we find is that the spring extends. Now when I add more and more masses, it's fairly obvious, but the spring gets longer. You don't need to be doing A-level physics to work that out. And what we can look at is the change in the length of the spring, the difference between the original length and then how much it's actually extended. And we call this extra length the extension. Because we like to quantify things in physics, what we can look at is how much force that we apply, or effectively the weight that we're adding, and also how that affects the extension. And I'm going to use the symbol X for extension. And what we find is as you apply a bigger force, the extension gets longer. And we actually get a fairly nice region like this, where the force is proportional to the extension. And we can therefore say that F is equal to Kx. And this is all put together nicely in Hooke's law. So what Hooke's law states is that the extension is proportional to the force applied, provided that the limit of proportionality is not exceeded. But really what we can see here is that the force is equal to Kx, where K is what we call the spring constant. So this spring constant tells us how much a spring or a piece of material will extend when a certain force is applied. And what we find is that we have different sorts of springs. This one here might be quite stiff compared to this one here, which is fairly lazy. And different springs have their own spring constants. So it might be that you apply the same force and we get a different extension. The important thing to note is on this graph here, the gradient is equal to the change in force divided by the change in extension, so effectively F over X. And that means the gradient is equal to the spring constants. So this one here, the blue one, might be this spring here that's very stiff. The spring that we have over here might be more like the green line that we have over here.